Just as a reminder here, a radian is a lot more than 1 degree. So 1 radian would be right here, this angle here that's 57.3 degrees. 2 radians would get us over here. 3 radians would get us over here. And notice we're not quite to 100. By the time we get to 3 radians, we're not quite to 180 degrees. 180 degrees is a little bit more than 3 radians, which is pi radians. So good things to latch on to are, again, pi radians is the same as 180 degrees. Fun fact, 180 degrees is exactly pi radians as we have seen before. Another way to convince yourself of that is this. Pi, or 3.14 radians, would be pi, or about 3.14 times 57.3 degrees. If you do that arithmetic, you'll get to 180. How many degrees is pi over 4 radians? How many radians is 60 degrees? Would you pause the video and see if you can work that out? Okay. Pi radians leads to 180 degrees. So half of that would lead to 90 degrees, and half of that again would lead to 45. So pi over 4 radians is exactly, 45 degrees. 60 degrees. All right, 180 degrees would get me pi radians, but I don't want 80, I want 60. 60. From 60 to 80, we took a third of that, right? If you do 60 divided by 180, you'd get 0.33, or 1/3. So if 180 degrees is pi radians, 60 degrees is a third of that, 1/3 pi radians. That would be our answer. It'd be nice if we could graph in radians as well as degrees. So as an example, let's graph this equation. To graph this, I'm going to first just draw the curve. It's a cosine, so it starts at the top, goes to the middle, and back up. I'll draw my y-axis here as well. It's centered, the baseline there, or midline, is at 5. The amplitude is 3, so it goes up 3 from there. And down 3 from the midline of 5 gets me to 2, and that means the x-axis has got to be down here. And I've got my graph. Normally, I would just label these key spots, 90, 180, 270, 360, but it told me to use radians. So instead of 360, remember pi radians is exactly 180 degrees. So instead of 360, that's 2 pi. 180 is pi radians, right? 180 is pi, so 360 would be twice that, or 2 pi. 180 is pi, so 90 would be half of that, 1/2 pi. And then 270 would be 3/2 pi. Right, so 90 degrees is half a pi, and then pi, and then 1.5 pi, and then 2 pi. So our tick marks are going by 1/2 pi's this time. For the second one, we're asked to get an equation for the graph. Looks like the midline is about here. I'm thinking of this as a cosine. So it's going to be cosine of something minus 5 for the midline. The amplitude is this distance from the middle to the top, so that looks like 3 units. The period for this, a wave starts here and ends here, so the period is pi over 2. Again, remember pi is 180 degrees, so pi over 2 would be half of that. So the period is 90 degrees. Normally the period is 360. We're going much faster this time. 360 divided by 90 equals 4, so we're going 4 times as fast. And that means it's going to be cosine of 4x here instead of just cosine of x. We speeded things up by a factor of 4. And you got your equation. For the last example here, this is one wave. I'm thinking of it as a sine function, so it's going to be sine of something. The midline is at 0, so no reason to write plus 0. I could if I wanted to, but it seems kind of silly. And the amplitude is 1. Again, I could write that if I want, but there's really no reason to. The period is 10 pi. One way to think about this is normally a period is 360 or 2 pi radians. So this went 5 times as fast. Oops, I'm sorry. This went 5 times as slow. So 1/5 x would go here. 1/5 as fast. Another way to do this is, can think about it in terms of degrees. Pi is 180 degrees. Pi radians is 180 degrees. So 10 pi is 10 times 180 is 1800 degrees. Normally a period is 360. This is much slower this time. So 360 divided by 1800 equals 0.2 or 1/5. So again, we get our 1/5 there for the equation, and we're done. So a nice thing to remember is pi is 180 degrees, 2 pi is 360. So the normal period would be 2 pi, but it took us 10 pi. So we're 5 times as slow. Or of course you could just convert degrees instead and do it that way. And that's it for radians.